So let's start with what is quality, why should it interest me, and how can we achieve it? I have some definitions. These are from like different authors who all have like a different view on what quality is. And the first one, like quality is universally recognizable. It is related to a comparison of features and certain characteristics of the product. That basically says like quality, you see quality when you see it, but like you cannot really define it properly. So it's like a very vague term. The next one is like totally the opposite, like quality is a precisely measurable variable. Like you have certain properties of like a product and you can measure these and yeah, based on that you can compute your quality. Another one like which is more practical is like quality is like if a product is fit for its purpose. Like if it does what it should do, then yeah, that is quality. And you can see that like depending on which view you have on code quality or quality in general, like there can be like a lot of different things what people understand under quality. To go to like what code quality is, like not only quality in general, but code quality, I think these three characteristics are like the most important ones. First, you want to deliver new functionality very fast. And not only very fast, but you want to deliver that fast all the time. Like you don't want to go like fast one time and then you slow down and it becomes really hard to add new things. But you want to go like at best like at a very steady speed to add new functionality. And so sustainability is really important. The second one is you want to not only make this work in like a small team, like if you're a single person, but you also want to make it work if you have like many developers who are working on a product. And these can be very difficult and be a whole other challenge instead of just doing it alone. And the other thing is you want to innovate and you want to react timely to changing business environments. So you don't not only want to go fast, but you also want to be able to go fast like in the other direction if it needs to be. So this is also really important, innovation and reacting timely. So what are the business benefits? Why is that interesting for us? This is also like very not code oriented, but this is really the business benefits, why the business should do it. First one is you have lower defects in software products. I mean, that's something that you obviously want to achieve. If you can choose between a product that has more defects and costs the same amount, like another product which has less defects, you obviously want to choose the product with less defects. So you get a better return on investment if you care about quality. You also at the same time achieve higher customer satisfaction. The people who are using your product have more fun if it has less defects than people who are using a product which has bugs all the time. So this is another point why you would want to achieve lower defects in software. And the other thing is you also create higher confidence between your business partners. If you deliver a software that has less defects, then your business partner will be more pleased than if he has to like tell you, hey, there's something not working, can you have a look? Yeah, that creates more trust between the business partners. The second benefit is that it creates predictability of software development. If we go at a steady speed all the time, then the development process becomes much more like predictable. You can create trust between internal partners. If you say like something takes a week and you go at the same speed all the time, then the business partner internally and externally can rely on that, and this creates trust. It also creates like pride of ownership, like developers who are building a product that has high code quality and who are not just caring about like getting the feature in, but caring about like getting the feature in the best possible way. This creates pride of ownership and is motivating for these developers. That's another benefit. Then code quality also makes the project more scalable. And I'm not talking about scalability of like the website, like serving a lot of users, but scalability in the form that you can add more developers to the project. If the project has a simple design, if it's not too complex, if like it follows certain guidelines which are the same for all developers, you can more easily add new developers to the team, and they will be able to add new features more quickly than if like each part of the code is like structured differently and only a specific developer knows how to like add a new feature to a specific component of the code. And in the same sense, it also reduces the dependency on like a single developer in your team if everybody knows the entire system. Velocity and agility. This is the benefit like that I talked about in the beginning. You want to go like very fast, and you want to be able to react timely to changing business requirements. And that is the benefit is that the system is more maintainable, and you can add more functionality more quickly. And you also have at the same time, if you add the same features in less time, you have the remaining time for like other requirements that are non-functional, that are no one is paying you for, like security, performance, scalability, reliability. These are basically cross-cutting concerns to like the actual functionality that your application has. And lastly, you're also able to innovate. Like if you have a like sound environment where the code is well structured, you can much more rapidly add new functionality. You can prototype, check out if an idea works, and if it doesn't, you just go back. So it's not really hard to add new functionality and illustrate ideas that you have to check if they work out or not. These are the benefits that you get from high code quality, and these are the ones that we want to achieve. And the question now is, how can we achieve them? Which practices exist to achieve these benefits? The first one is to have like what I call an agile architecture. You would want to have an architecture that you can constantly evolve. You can constantly evolve the design, like you do not plan the design ahead, like up front you make drawings and diagrams and whatnot, but you basically adapt the design at the time when you develop and add new features. You do that at the same time. You add new features and you adjust the design to accommodate for these new features. And how that works is like principles like emergent design, intentional architecture, design simplicity. You don't want to have like a complex system, but you want to have a system that is made up of simple components. The entire system can still be complex, but the individual components are simple. Design for testability. You want to have like continuous integration. You want to test your code all the time. Prototyping, like I mentioned, to like check out new ideas. And domain modeling. Second one, continuous integration, inspection. You want to find regressions as soon as possible to address them as soon as possible. You want to create accountability, like the person who introduced the regression should ideally also fix it because he also knows best where and how to fix it. And it also creates like kind of peer pressure to not break something. If you do not have continuous integration and like just run tests like I don't know how often, once a week or something, then yeah, you cannot really say who broke the build if it broke, and then you will have a discussion who broke it. So it's good to have that like set up continuously. The second one is refactoring. This one is like the key enabler for having an agile architecture, because you need to change. You do not plan up front like how the design of your application looks, but you do that like all the time when you add new features. And to change the design, you need to have like refactoring to evolve the design to a state where it can accommodate for the new features that you want to add. So this is really just necessary and actually a very integral part of the entire agility. And the fourth practice is collective ownership. That ties in with the scalability of the team. If everyone can change every line in the code, then you are not dependent on a single person, and you can add more developers more quickly. And for that, you need to have like a proven and agreed to coding standard. And I'm not just talking about like coding style, that's one part of it, but a coding standard, how things should be done. And you also need to have simplicity in design so that everyone really can understand the feature without having written it. And you also need to share knowledge, obviously, so that the code can be understood. Yeah, that's to the practices, and now we come to the part where we actually see some code and some practical examples of how this can be done. The first one is emergent design. That's the one that principle that we use to achieve a agile architecture by evolving the design constantly while we add new features at the same time. And how does that work? Basically, we start with a view of the system that we already know. We know what the system should do at some point. And we start with this initial design. And as you learn more and you get new business requirements, you change the design to accommodate for these features and add them at the same time. The alternative approaches, just for reference, would be, for example, to have no design at all. Like you just add the feature like without thinking about it at all. Or you do like upfront planning and like imagine what the system might look like in the future, and then draw some diagrams and like map out the entire system before you start like programming, which is like you can do that, but if something changes, some business requirement, then that's not such a good idea. And how can we achieve emergent design? What we need for this is refactoring to evolve our current design to the design that we want to have to accommodate the features. And we should at least know some of the design patterns so that we have an idea like how can we transform the design. But design patterns are really, you should be really careful with these. It's not like the solution to a problem. It's like one solution to that problem. And a design pattern is much more effective because you know if you know when it is used and why it is used. Not just like applying a design pattern per se because like it's a design pattern, but you should know why this specific pattern was used. And to gain these insights, you can apply them to your problem that you have at hand. And what you want is you want to have a maintainable design, and that's just as much design as is needed. So you don't want to over-design, you just want to have the right amount of design to accommodate that feature. How can we know when we have to refactor? There are several techniques. Code metrics, for example, are the one thing that is really measurable and that can help to decide when to refactor. There are really many metrics out there, and for refactoring, these are really not useful. Most of them give like an overview of the entire system state. And that's for refactoring, and an entire view of the entire system is usually not useful. If you want to refactor, you mostly have like a very small part of the code that you want to refactor. And the metrics that I personally find most useful are complexity, readability, and duplication. And we will see examples of how I can reduce the complexity, increase readability, and also deal with duplication later on. And the alternatives to that is, for example, you could also say if you don't want to use code metrics, for example, if you have an open source project, code metrics are probably, because you're working on the project alone, code metrics are probably not necessary. Alternative approaches are things like code that annoys you. Yeah, if code annoys you too often, then you want to refactor it. Or the other method is like basically the same thing. Like each time that you want to refactor a method, you make like a scratch, and if you have enough scratches, then you go ahead and refactor that method. But if you want to have something measurable and you have a bigger team, then code metrics are really helpful to decide when to refactor. So let's take a look at an example of how we can refactor some code to make it less complex, more readable. What we have here is a Symfony controller that is supposed to launch AVS instances. And it uses it creates a form to define some of the instance properties and then sends API requests to Amazon to start that instance. We also see the picture of how this looks in Scrutinizer. You get a rating of the entire method, and you get individual ratings of the different parts of the code. Like in this case, we have the complexity, we have the amount of conditions that are in the method, we have the different paths that could be executed depending on how the conditions evaluate. We got readability in terms of how long is that code, how often do I have to scroll to view the entire method. And okay, it's also not covered by test, obviously. And this is the entire code that we want to refactor. So it's pretty long, and we will now start to refactor this bit by bit. So this is the beginning of the method. What we do here is we want to get the region in which we launch the AVS instance. We have a custom string that we get in the query, and we transform that to the Amazon string. Then we have the EC2 client, which makes API calls. And here in this section, we retrieve the available images which can be used to launch the instance on AWS. So if you look at that code, the first typical example that I would look for is to find units in the code which we can extract to separate methods and which are doing something in common. And the first thing that I would extract is this part here where we determine the Amazon region because it's a separate task and we can easily extract that into a separate method. So if we do that, then we just have the call to a separate method, and we got rid of all the if conditions which check which string is passed and transform it. So that's already a very good start. We commit that code, and I want to show you how that looks on Scrutinizer. If you commit code, then this is automatically analyzed by Scrutinizer, and you always get not the complete state of the project, but you exactly see which parts of the code have changed. In this case, we have added a new method to the instances controller, and yeah, that was rated with B, so it's pretty good. So we don't have to adjust anything. We also see that the total quality of the project has improved a bit, which is also nice. And what we also see is that we have introduced an issue. So let's take a look at what went wrong there. And yeah, we obviously forgot that we used the variable which we extracted in the code. So Scrutinizer not only takes code metrics, but it also is more like a compiler and also finds bugs in your code. Since we didn't test this method, this is really helpful. Okay, let's go ahead and take a look at the next section. So we have reduced the first part, we have extracted this, and yeah, the next logical part, the next logical unit would be to get rid of the entire image code here and extract that to a separate method. So let's do that. And when we apply that, we have the first call that we extracted, the second call, and now we go to the next part and take a look at what part, what section, what unit forms a part of code that we can further extract. And yeah, the most obvious thing that comes to see is the entire form part. This is a logical unit that we can easily abstract and than just assign the form variable from a method call. So if we do that too, then yeah, the entire method really got small, and yeah, you also see like what the entire method does. That's another benefit if you have like names. If you name your methods like appropriately, you can like read the code from from top to bottom and really easily understand what this method does. So we get the region from the request, we generate some image choices for our forms, and then we build the form. So the next part is just the same thing. We are looking for more code that we can extract to a separate method, and that is to generate the launch data. It's actually much larger to generate the launch data. I'm not showing the entire code here. But if we extract that as well to a separate method, this entire controller that we saw in the beginning is really small, and you can now see the entire code. And it got really more readable. We didn't do anything fancy in terms of refactorings. We didn't apply any like complicated design patterns. We just took some code, copy-pasted it to a different section, and added some more methods. So it wasn't really hard, but the entire controller is now like readable. Like you can see it without scrolling. You can like understand what it does, and it's really easy. And yeah, that's the power of like simple refactorings, to get more code that is more understandable by people who have not written it. So let's look how this. First, another benefit of like having the code in this way. Some people might say, okay, if we extract that, like we have more method calls, and like my performance might go down because of these additional method calls. In my personal opinion, I would not make any performance decisions just based on like method calls, but you would need to have like actual data if you want to talk about performance. And in fact, because we have like extracted the method in these different parts, this makes it more easily to actually profile where you have a performance bottleneck, like because you get a much more fine-grained performance analysis if you have like many small parts than if you have like big methods that do a lot of work, because you don't know where the time is spent in these big methods. So if you have smaller methods, you can more easily spot performance regressions. So that this is just a side effect of having refactored and simple code that is made up of small components which form like a bigger system. So let's look how this looks on Scrutinizer if you commit the code. The previously rated method has now like improved considerably from F to B, and we also added 2 new methods. We could like go ahead and refactor the individual methods again, but I think it's not really necessary. We also see that like the overall quality of the project has increased, which is pretty cool. Now I want to go to a second example. Now we saw like how can you make code more readable, how can you make it less complex by just like moving some code around. In this example, we will keep the general domain, like we have still our instance on AWS, and we like have a class that is like an aggregate, like it aggregates many instances, and it adds some additional methods on how to retrieve instances from our list. So this one method here retrieves the running instances from a list of instances, which maybe also contains like stopped instances, for example. This is pretty simple. But now we want to have to add another method, like a method that not returns the running instances, but maybe it returns to the instances which have been started in the last 30 minutes. So we go ahead and add a second method. And what you can see already is that we have some sort of duplication. This is not really there's not really duplication in the actual code. It doesn't do the same thing, but the duplication is like in the way how this code is structured. Like we have a loop, we do a method call, and we aggregate the result in a new variables. So you have some sort of duplication here. If you take, for example, this part and only this part here differ in both methods. So let's see how this looks on Scrutinizer. It has found that you have like similar code here, and you can also like directly see or view the different parts in your code that are duplicated. There are different forms of duplication. That is literal duplication. Like if you copy-paste code from one part to another, that's like the most simple form, but it doesn't happen that often. Then, yeah, duplication in the structure of the code, like if it like does the same thing, like we see here, for example, like I said, like the same loop that we have and the same method calls maybe. And then we also have like a difference between intentional duplication and unintentional duplication. Like if you have a big team, 2 developers might write similar code without actually knowing that each of them wrote similar code. So in that case, like duplication detection helps as well. How can we fix that? In this case, like the first step that I would do is like introduce like a generic method that receives some form of dynamic input that does the decision. In this case, like a callable on PHP is usually sufficient, and we pass in a callable, and this callable like checks if it returns true, if the predicate is satisfied, and if the predicate is satisfied, then we aggregate the variable. And in our actual get running instances method, we can just like pass in a function which contains the code that is different from the other function. And we can also add the second function and just pass in a callable that contains the logic of the other function. And that way we have reduced the duplication in the code. Why should we do that? Well, it's simple because it has 2 benefits. When we want to update the code, then we don't need to update each place where it happens, but we just can update a single method. For example, if we want to add additional filtering rules, like we do here, for example, we have an ACL rule and check if it's accessible. If we would want to add more of these checks, then we would only have to do that in a single place and not in several different methods that we might not know about. Another factoring that we could also go a step further here if you wanted, and like you can say that, yeah, okay, but the ACL filtering doesn't really belong there, it's a separate concern. And we could also go ahead and make something more complex here and, for example, create an interface for the list and then have a simple list which just contains my methods and a separate list for the ACL part, which like filters the which is a decorator pattern. It filters the return value of the inner list. This is like a more elaborate thing. The benefit if you do that is the code becomes even more testable, and it's also a separation of concerns. Like you have one list which just does the filtering based on the functional requirement, and then you have a second list which does the filtering based on like the security concern, like the ACL, for example. So that makes our code more testable, which leads to the next thing that Scrutinizer can help you with, and that is running test. I don't want to talk much about the testing part of Scrutinizer. It's really simple. The key things are that it's specifically designed for web projects. The dependencies and the services that we install are specifically designed for web projects. We, for example, have like easy setup of browser-based tests so that you can use Selenium or whatever, and you don't need to start any virtual frame buffers or something. That's already done for you. We also start like common services like MySQL, Redis, which are used very frequently. And for like most configuration, like most of the time you will just need to add the project and the rest is automatically inferred from your composer file and your general project structure. Then the next part is the other checks. We had code metrics, and now we go to the more hard checks, as I call them in Scrutinizer, which is to find bugs in your code. And I want to talk about the general architecture that Scrutinizer uses and why this is better than like that of other tools that are available on the market. And Scrutinizer is like a compiler for PHP and provides you with some of the compile time benefits that like statically typed languages have, which have like a built-in compiler. And like this example here is from an actual code base. And what happened there is like you have like the property was annotated as an integer, and then the price method, the setPrice method, is actually annotated as a float, which is obviously not what you want. So like this could like go badly if you pass in the wrong value and then someone is charged. You don't really want that to happen. If he's charged too much, then at least he will let you know. But if he's charged not enough, then you will likely lose money in that case. So this is just a single type of check. The general analysis that we do is like that a compiler does like control flow analysis, data flow analysis, abstract interpretation, variable readability, and a couple of more. And these allow us to like get a very precise view of how your code works internally. And these allow us also to make very sophisticated checks like the type safety check. This is the one that you see here, for example. We can also check for, or do check for dead assignments that are like assigning to a variable that is not really used in your code. General unused code detection, like unused method, unused parameters. We also do security analysis. We will see some examples of how that looks. Like if you, we analyze the call graph to see like if you pass like sensitive data or raw request data to some sensitive functions. That is part of the security analysis, and a couple of more. One of them is the undefined variable example. I just want to pick that to like make a difference between like a simple approach, naive approach, and how Scrutinizer and the data flow analysis part of Scrutinizer helps to make these checks better. So here we see a simple function, and we assign a variable in like a switch statement. And at first sight, you might think that x is always defined here. But it's not really, because in this case, we handle two input variables, but we do not handle the default case. So if another value than foo or bar is passed for the a parameter, then x is not defined at this point. And that's one part. If you use a naive approach and just look at the method and like check all the different assignments in that method, you would see, okay, x is assigned, but at this point, x is not really assigned if you follow the flow through this, this method. Basically, what Scrutinizer does, it has a view at this point of the method. We have a different view of what variables are defined than at this point, or at this point, or at this point. And while x is defined at this point it's not defined. So this is something that Scrutinizer and the compiler-based approach that is based on data flow analysis can give you over that simple approach that some other tools use. We also do this like if you have like assignments and conditionals, for example, and expression trees like this one, that's also no problem. So we can check for this as well. Another feature that Scrutinizer has, I've talked about this in the beginning, like if you have like a bigger team and you want to have like a collective ownership so that everyone can change every part of the code, you would want to have like a common set of coding standard. And part of that is to have like a common coding style. And Scrutinizer is really configurable, really flexible in what kind of coding standard you want to use. Like there are, at least for PHP, there are 109 different checks that you can choose from and enable on your project depending on what makes sense. And it's really easy to set up. We do not force you into anything specific, any specific coding standard. You can, for example, enable PSR1, but you can also use the Drupal coding standard if you have a legacy project. So that's really your choice. We also fix like many coding style things automatically for you, and you can apply patches. This really makes it easy to fix them, and you have more time to focus on more important or functional things during the actual review phase, and do not need to say like, okay, the coding style is not correct here or something. So you can make the coding style fixes before doing the actual review of the code. Another cool feature that we have is like weekly code quality reports, so that you see like you get a weekly email and you see like which people have worked on the code, how much commit activity was there, like were new issues introduced, were there critical issues which have been introduced and not been addressed, or were there drops in the rating because like the complexity got too high or the code got unreadable or something like this. So this is another thing that Scrutinizer offers you. Last, I want to go to the security analysis part of Scrutinizer. The OWASP, it's an open web application security project, and the most critical security issue in 2013 were injection attacks. There are many different forms of these attacks. One is, for example, SQL injection. In modern PHP, this is usually not the common one because we have Doctrine and we have other abstractions which usually make it very easy to avoid these forms of attacks. Other attacks are path expansions, like if a path can be injected by a user, or XML entity injection, like if you can like include another file in an XML document, load from another part. I think there was also a very serious security issue in Symfony a couple of years ago. Command injection, if you can inject a dynamic part into a shell command, or like if you can write code on the file system and do like introduce your own code onto the file system and execute that. So how does Scrutinizer help you with that? First, what I call simple example is SQL injection. Like this is pretty obvious that this is not good because you pass in a dynamic parameter into a DQL query, which the user could manipulate and gain access to instances that he shouldn't really have access to. This is pretty simple to detect because we just need to parse like the local scope of this method and see if you pass in dynamic variables. But we do also a more extensive analysis in our second example that I want to look at. In this case, we have our instance from the previous example, and we want to allow users to pass in a configuration for that instance, which we store in YAML format. And what we do first is like we parse the YAML to see if it's correct. If not, then we add an error that the YAML didn't parse, and then we set the data on the instance. It's a text type, so we store the raw YAML data on the instance. We also have like a convenience method which returns us the parsed configuration in case we need to interact with it. So the question is this code secure? Since it's an example, it's probably not secure. So let's see what Scrutinizer thinks about it. Oh, we have passed raw request data to file get contents. If we pass raw request data to file get contents, this can be very serious because like someone can gain access to any file on the file system and read, for example, your parameters file, which is, for example, possible with this. And why is that happening? Because in the YAML parse method, there is a call to file get contents. Let's see how that looks. So if we look at the YAML class, it has a not so known feature, I think, that if the input is a file, then it expands the input with the input of the file and then only parses that input. That is used, I think, by the dependency injection component of Symfony. And if you don't know about that, you can add a security hole to your system very easily. For example, if you pass in this variable as a configuration variable in the form, then you could gain access to the parameters file of your Symfony application. So you obviously don't want that to happen. And Scrutinizer helps you with finding these call stacks which lead to these sensitive methods like file get contents, or other methods like unserialize, for example, is also one candidate, or fopen, or file put contents. We parse all the stacks which go to these methods and see if you pass in raw request data. And if you do, then we notify you of that problem. This not also only works if you go this direct path, but we can also detect more complex things. For example, in the same example, we passed the request data to the constructor, wrote it to a property, and then we have this getParsed method which reads the property and then calls the parse function. And we can also track that, and we'll notify you if you do that. And the cool thing is you not only get a message like saying there's a potential security hole, but you get like the entire stack trace, so you can debug like if this is really an issue or if it's not. And I think that makes it really easy to to validate this issue. And yeah, that's it. Thank you very much. Bye. If you have questions, I think we have a bit of time.
Hello, thank you for your presentation. I was curious if there is a way to deal with legacy code base, rather large legacy code bases, and if there is a way to kind of turn off every security, every check style, every alert on what's already committed, and only have alerts and reports on things that comes in the code base.
Yeah. Well, the cool thing about Scrutinizer is, like I showed also in the example, is that if you commit code, we show you like what changed in the part that you changed. So you do not get like a report for the entire project all the time, but you get really a report for the things that changed in the project. So this makes it really easy also for legacy projects to like just care about the new code that is added, and not like have to worry about the code that's already present and that maybe has a lot of issues. And the other part is we also have a feature that lets you like filter issues. Like if some check does not work on your code, you can like say either ignore this instance of the issue, or you can also say like ignore all instances of this issue, and then your entire project gets filtered and these issues are not displayed anymore.
Okay, is there a way to ignore part of files instead of a type of issues?
Yeah,
yes. Okay.
That's like how this works. Like if you ignore that issue, then like it doesn't pop up in the code anymore, and also not in the future code, basically.
Okay, thank you.
How does it compare to system like Sonar? You know Sonar?
Sonar?
Yeah.
I haven't used Sonar, but as far as I know, they use open source tools for the analysis. So it's like some of the things that I showed before. These open source tools usually use the simple approaches, which find some types of issues, but which are not as precise. And Scrutinizer uses the compiler approach, where we do the data flow analysis and the control flow analysis. You do not find as many issues, and those issues that you find are often also not as precise. That's one difference. And like the security analysis part, I don't think that this is available for Sonar, for example.
And another question: can I manage other kind of project like JavaScript or PLSQL code with these tools?
Yeah. Currently, we for JavaScript, for example, we just offer like that you have lint checks, like some basic things that, for example, JSON does. We have also support for Ruby, for example, and for Python, which are like more complete than the JavaScript support. But yeah, Ruby, Python, and PHP is currently supported.
Thank you. And another one? How does it? How many does it cost?
It costs for the startup package. It costs €49 each month.
Excuse me. Here. You said that there was some automatic fix about coding standard or even I don't know, other issues. And what is the workflow of this? Does it go to the version system, or how is it?
How you apply these fixes, or?
Yes, are they applied automatically, or they are just suggestion and then we have to?
There are two ways basically. We generate a patch that you can use and apply to your project, or you can also like get a pull request from us and then merge that into your project. So these are the two options.
Thank you.